Okay guys, welcome to this A2 pure level maths here exam style questions. Okay, and I got these questions here from like a website here called Mathsbox. So yeah, Mathsbox here is like a fantastic resource website here for GCSE maths, key stage 3 maths here, and also yeah A level maths as well as here for pure maths here and mechanics and mechanics and stats, guys. Okay, so we've got 3 questions here, guys. Here, so feel free to totally pause the video, try and attempt the question or questions, and then come back and press play. And please do obviously take any notes, okay? But I'm treating this video as like a revision video, okay? So I apologize if it is a bit fast paced, but hopefully it makes sense, okay? But again, obviously pause it at any stage, and obviously rewind as and when you need to. Okay, so this is the first question. Express 13 subtract 5x all over 2 minus x, x plus 1 in the form a over x 1 plus x plus b over 2 minus x. Okay, so this topic here is called partial fractions. Okay, so we've got 13 minus 5x. Okay, so if we multiply everything here by 2 minus x and x plus 1, so it's equivalent, so it's equivalent to this. Okay, we get as follows here. So we'll get this is equal to or equivalent to as follows. So a lots of 2 minus x plus b lots of 1 plus x. Okay, so hopefully you're happy with that step there. Okay, so I made these two like equivalent or equal to each other. And then just like cross actually multiplied there, but I times everything here by 2 minus x and 1 plus x. Okay, and it gave me as follows. Okay, so I'm now going to substitute in here like a particular value to work out what a and b are. So if I let x equal to 2 to work out what b is, okay, because that will eliminate the first bracket, because 2 minus 2 goes to 0. Okay, so I get 13, subtract 5 times 2, which is going to be 10, is equal to b brackets 2 plus 1. Or 1 plus 2, sorry. Okay, 3 is equal to 3b. Dividing both sides by the 3, okay, we will get that 1 is equal to b or b is equal to 1. Okay, so either answer will give you the same answer, okay? So b is equal to 1. Okay, for that, okay, so b is equal to 1 if you're interested. So I can replace that with the number 1, okay? That's the first part there, guys, okay? The next part, okay, I'm going to let x equal to minus 1. And the reason for that is then it eliminates, the value of b. Because, if x is minus 1, then I have 1 plus minus 1, which is 1 subtract 1, which is going to be 0. And I get left with a. So I'm going to let x equal to negative 1. So 13 subtract 5 lots of negative 1. Okay, so I'm going to be obviously careful here with my signs. Is equal to a lots of 2 subtract 1. Sorry, 2 minus negative 1. Okay, which obviously goes to 2 plus 1. So being careful, because it's 2 minus 1, guys. Hopefully it makes sense there. Because obviously minus x goes to plus 1. Okay, so working this out, I get 13 plus 5 is equal to 3a. Okay, so you get 18 is equal to 3a. Dividing both sides through by the 3, we get that, 18 thirds is equal to a. Therefore, a is equal to 6. Okay. Okay, so a is equal to 6. Okay. And that would obviously be my final answer. Okay. So your final answer is just obviously writing it out as the fraction but obviously separated. Okay, and this topic here is called partial fractions. Okay. So it's taking a fraction and obviously like splitting it up here in just like these different components here, if that makes sense. Okay, and this is important actually because a part B may say like integrate this function. Okay, obviously that is now in a format here where I can actually obviously integrate it. But the first form here is not like an I can't actually integrate like the actual first part because I'm not actually like decomposing, if that makes sense. So I can now integrate that or do any like other question for that. Okay. The next part, so expand in ascending powers of x up to x squared for part A. So 1 plus x to the minus 1. Okay, so the formula here in your formula booklet, guys, here for your A-level maths, okay, is 1 plus nx. Okay, so n is equal to -1 here. Okay, so n is equal to -1. Okay, and x, x is just equal to positive x. Just to make it clear. So x, is just equal to positive x. Okay, so you have 1 plus nx, so that'd be 1 subtract x, because minus 1 times x here is going to be minus x. So you have obviously 1 plus minus x, which goes to minus x. Okay, and then you've got plus n brackets n minus 1 all over 2 factorial times the x squared. So I'll put it in brackets here, so I'm putting an x like that. Okay, squared. Okay, and the reason for this, guys, is because in the exam, it might be like a 4x there or like a 9x here. So remember that you're squaring like the whole thing, okay, together. Okay, so I'm going to have 1 subtract x. Here I'm going to have -1 times -2, which will be positive 2. 2 factorial is just equal to 2. So 2 divided by 2 is just going to be 1 times x squared here. So it's going to be plus x squared. And then plus ... Okay. Sorry, x squared, just obviously make it clear. Okay, Okay. Sorry, guys, about this. So plus the x squared, obviously plus ... Okay. Okay, but your formula booklet will have the formula here for that. Actually, remember that it's in the form 1 plus or minus x, whatever it is, to the power of n. Okay, or 1 plus or minus like I don't know, like ax. So 1 plus or minus ax all to the power of n. Okay, for that. Okay, and the formula it is in like your actual like formula booklet, guys. Okay. For part B, again, I've got to be obviously a bit careful because it's a bit more trickier. I've got to factor out 2 to the minus 1, and the reason for that is because it has to be in the form 1 plus or minus ax all to the power of n. Okay, in a minute obviously I've got to do that here, so I've got to obviously factor that out. So 2 to the minus 1, and then it's 1 minus x over 2, or 1 minus a half x. Okay, to the minus 1. Okay, for that. So 2 to the minus 1, guys, is just equal to a half. So that will just simplify to a half brackets 1 minus x over 2 to the power of minus 1. Okay, so again, I'm going to have so being careful. So I've got this half at the front. So a half brackets. So it's 1 plus nx. Okay, so negative x over 2 times positive -1, sorry, goes to x over 2. Okay, plus n minus 1, so that'll be minus 2. Sorry, I'm doing it in like one stage here, divided by 2 factorial. So 2 factorial, if you're not sure what that means, just means like 2 times 1. Okay, so n factorial just means n times n minus 1 times n minus 2, so on and so forth, until until you get to like the number 1. Okay, for that. Okay, so that'll obviously be 2. Okay, and then it's times by gotta be careful. It's times by a half x squared. Yes, times by negative half x squared. Half x. all squared, and then yeah, and then I've got the plus dot dot dot. Okay, and I'll close the big brackets. Okay, so simplifying this now, yeah, so taking my tabs, I'm going to have a half brackets 1 plus x halves, or x over 2, or a half x. That'll be minus 1. So minus 1 times positive a quarter x squared. Yeah, so that'll be minus a quarter x squared. Oops. Hard to make clear, yeah. So 4x squared, yeah. So the x squared is obviously part of the numerator, okay, plus dot dot dot, okay, for that. Okay, the last part, yeah, is just obviously expand it. Okay, yes, I'll delete, yeah, some bits for that. Okay, so hopefully, yeah, I'll just delete that actually, just so we've got a bit more space. So expanding this bracket, I get as follows. I get half times 1 is going to be a half. A half times x over 2, or x halves, will be a quarter x, or x over 4. Okay, and then I'm going to have minus, yeah, 1/8, obviously x squared, okay, plus dot dot dot, okay, for that. Okay, yeah, to make it a bit more clearer. So minus that, okay, for that, okay. And it says, yeah, obviously up to the x squared term here. So make sure, yeah, that you obviously answer the question here by going up to that, yeah, binomial actually, or the power for that, okay. Hopefully it makes sense, okay. For that, okay. So final part here is obviously, so find binomial, yeah, approximation says, yeah, as far as x squared term of this expression, okay, yeah, this algebraic fraction expression. Okay, so I'm going to be careful here. So remember, it's in the form, okay. So I'm going to have 6, remember, yes, obviously 6 lots of 1 plus x to the minus 1, okay, plus 1 lot of 2 minus x to the power of minus 1. Okay, yes, I'm adding here. Yeah, so it's 6 lots of all this here. So it's 6 lots of 1 minus x plus x squared. Okay, so that's obviously come from here, the part A, yeah, of the second question, the binomial expansion, using the formula booklet. Okay, plus obviously, yeah, dot dot dot, plus obviously 1 lot of here, so it doesn't actually matter here, so plus 1 lot of all this, so plus a half, plus x quarters, or x over 4, minus 1/8 x squared. Okay, plus dot dot dot. Okay, so expanding this out, guys, 6 lots of 1 is going to be 6. 6 lots of minus x goes to minus 6x. 6 lots of x squared is going to be plus 6x squared on here. And then I've got plus a half plus x quarters, or x over 4, minus 1/8 x squared. Okay, yeah, so collecting like terms. Now, obviously, A level, yeah, calculators, yeah, can obviously be used. So, yeah, so simplify it, yeah, by obviously collecting like terms. So we got 6 plus a half, yeah, it goes to 6.5, okay, or 6.5. Okay, minus 6x plus a quarter x, so minus 6 plus a quarter is actually minus 5, yeah, 0.75 actually, or minus 5 3/4. Okay, x. And then I've got 6 minus an 8, obviously x squared. So 6 yeah, is equal to 48/8. So subtract the 1/8, but again, yeah, I can do it on my calculator if you're not too sure. Okay, is equal to 47/8. Okay, which is equal to yeah, 5 7/8. So yeah, so plus 5.875, okay, x squared. Okay, like I have put it in like decimal, yeah, here actually, yeah, which normally I don't do actually, yeah, but I just, yeah, I'll try to obviously make it a bit easier for myself this year. But of course, yeah, like writing it as improper fractions, yeah, or mixed numbers would also suffice. Okay, and that is my answer for this last question here. So finite approximations, so it's approximately equal to that. Okay, that's my answer for the third question. Okay. Right, guys, that's the end of today's video. Yeah, looking at exam style questions here for the A2 pure math section. So yeah, we went over partial fractions, binomial expansion in the form 1 plus or minus, yeah, ax all to the power of n. So remember, yeah, so remember it has to always be in the form 1 plus or minus, yeah, like mx or whatever it is, yeah, to the power of n. Okay, if it's not in that like form, then obviously factorize out, yeah, the appropriate, yeah, like number and power, and remember, yeah, to obviously factorize out, yeah, the whole bracket as well. Okay, yeah, and you do that actually. Okay, so this one, yeah, I factored out, yeah, obviously like 2 to the minus a half out of the front, and then I got 1 minus x halves, okay, to the minus 1. Okay, that's my answer, yeah, for that question. Okay, yeah, and then a bit of, yeah, like binomial expansion at the end, approximations. Okay, hopefully, yeah, it made sense. Hopefully it was useful. If you did find it useful, don't forget to like, don't forget to comment, don't forget to subscribe, and I'll see you all inside the next revision video for A-level pure maths. Okay, take care, all the best, see you soon, guys. Bye for now.